testing matrices. What are the testing matrices? So guys, basic measures and derived measures. So what is basic measure? Basic measures, whenever we do some kind of testing, we do have some matrices, some parameters, right? And what are the derived? Derived means as per the project requirement, whenever it is needed, we customize it. Okay, we design it according to the project, to the product, the software, the requirement. Testing matrices is a tree structure. Effort variance is called EV. Schedule variance is called SV. Severity of the defects, weightage of the defect. It means, say for an example, on the basis of 50%, 20%, 30%, what is the weightage? If we are saying that something is giving an error, giving a defect or bug, then what is the weightage percentage of that? Defect density and defect removal efficiency. Now, matrices login are basic features are what? Size of the project as discussed, functional points, efforts, percent days. It means how many percent needed for how many days. Calendar days, schedule, okay. Defects category wise, number of defects and weightage defects. Team size, number of team members. Derived are what? Effort and schedule variance. It means defect density, weightage defect per FP. What is per FP? So guys, per FP, if you want to know, it is nothing but whenever we are testing something, right? So in the effort and the schedule variances, what is known as how many days it will require and how many people it will require to complete this testing. Okay. Next we have defect removal efficiency, means how soon we can remove the defect of that particular program following matrices of login. Testing matrices are what? This is the tree. Effort variance, schedule variance, defect density and defect removal efficiency. Now effort variance is what? So basically percentage of the difference between the planned effort and the actual effort applied on the project is called an effort variance. Okay, so I hope you will be able to understand. So say for an example, planned percent days of the project. What does that mean? It means that whenever a project comes to a company or as a team, whenever we are assigned to a project, we first need to calculate that within how many days we will be able to deliver the software, or we are assumption based on the assumption, or we are based on the calculation that how many days it can take to complete that project. Actual percent days of the project, it means if 3 people are working on a same project 8 hours per day and they will be working for next 10 days, then that will be actual percent days of the project. Effort variance can be calculated as follows. How? Effort variance equal to the formula will be actual percent per day. This means, say for an example, if I need, here it is mentioned 100, if you take 50% we need, and the planned percent and actual percent difference is nothing but you can just consider this in this way, that the actual say for example a building is getting built, okay. How many labors you need and how many labors you have now. This is the difference of actual percentage and the planned percentage. That planned percentage we are planning, we are assuming that okay, this planned days the software will be completed, the testing will be completed, we will be able to deliver the project to the client. And the actual percentage are what? It means actually how many people, how many hours of work for how many days they are providing. And the planned percentage would be divided by the planned percentage into 100. So we'll be getting effort variance for the given example will be 5%. Why? Because the actual percentage is 100 and the actual percent that we have is 105. So it will be 5%. Effort variance can be negative also. It means how it can be negative? Well, it can be negative when the planned percentage, okay, and the actual percentage has a huge difference. So if, say for an example, planned percentage is 100 and actual percentage is 2, 5 or 10, it is going to create an issue. Affect project manager, of course, because the project will not completed at the time. Schedule variance is what? Percentage of the difference between the planned calendar days and the actual calendar days been taken by the project is called schedule variance. Example, planned calendar days. Say for example, I am planning to deliver this particular project or to finish up this particular project 100 days. And what is the actual calendar days of the project, which is currently running? That is 112. It means 112. So schedule variance will be actual calendar days, same formula, actual calendar days minus the planned calendar days divided by the planned calendar days. So it will be 12%. Schedule variant can be negative as well, and project manager is the responsible person. Severity of defects, it can be high, it can be medium, and it can be low. Okay. High, project 1, project 2, project 3. Okay. So it says total defects. How many defects are there? Total 80 defects. How? Because project 1 contains of, say for example, number of high 10, project 2 contains 20, project 3 contains 15. It means, to understand it in a better way, project 1 number of high severity that needs to be fixed ASAP. Project 1 we have 10 defects that are in high severity. Project 2 we have 20 defects that are in high severity. And project 3 we do have a 15 project which is 15 defect which is in high severity, and similarly for medium and low. So what we will do, we will first calculate the project 1 80, project 2 80, and project 3 80. Now here you can say that how we will be understanding that which product we needs to be fixed first. Correct. So we'll be looking that how many number of projects are having the high severity. So if you see it, the project 2 is having the highest severity with 20 defects in its list. Correct. Now we will be talking about the weightage of the defects. We cannot say that which project it was. Can we say from this? No. Unless we assign a weightage defect, thus the defect becomes weightage defect. We assign weightage as, say for example, so with high, low and medium, we can't be able to figure out, right? So for that we need to give some number to that. So we are giving a number. Say for example, we are giving 5 to high, we are giving medium 3 and low 1. Okay, weightage defect for the previous example. So this chart will be, let's see, first high 10 into, will be including giving 5 for each. So for high, for every high, project 1 high, project 2 high, project 3 high, we have multiplied with 5. The number was, whatever the number of high severity defect was, we have multiplied that defect number of severity into 5. So we get 50, 100, 75, 60. So what is the total defect weightage? 160. For project 2 190 and project 3 180. Correct. Hence the project 2 is worst, which we have analyzed on the first. Correct. So you will be also able to analyze once you become experienced tester. So next we have defect density. Now what is defect density? Defect density is known for functional point or function points of the project. It means whether the software or the major module, the critical module, are functioning or not. So defect density is the weightage defect divided by the size of the project. So from previous example, so we are taking the example of the previous table. Weightage defect is 160, 190, 180. Size of the project is 160, 350 and 530. Defect density is 1. How? 160, 160 if you divide it will be 1. 190, 350, 0.5. 180, 530, 0.33. What is the defect density? 1. So according to defect density, project 1 is worst. You might have that question that here project 1 is worst, here project 2 is worst. How come? So guys, try to understand this. Each of the defects, okay, the weightage defect, right, severity of the defect and the density of the defect, both three of them are different things. So you need to understand. And when we are talking, when a manager said that, okay, let me know that what will be the defect weightage, or let me know the severity of defect, or let me know the weightage defect, then you will be what doing? You will be just multiplying 5 for high, 3 for medium and low for 1. For which one? With the number that is being assigned as a defect number. Defect number that was assigned to project. Here we are multiplying 10 with 5. right? What is 50? 175. Then once we total this, we get that 190 means project 2 is worst. But in terms of what? In terms of weightage defect. If, okay, calculate the defect density. What we'll be doing? We'll be taking project 1, 2, 3. What is the weightage of the defect? 160, project 2, 90, and 3, 1. Basically 160, then 350, and 530. Now we come to know, once we divide the weightage of defect, and we know that project 1 is worst. Depending on what? Depending on defect. If the defects